Hello, let's continue our Sudoku adventure with Chaos Rising by the Asylum. So this is a chaos construction. So we have 6 by 6 chaos construction rules. That means in every row and every column, we are placing the digits 1 to 6 exactly once each. We also have regions hidden in the grid. Maybe, I'm not going to follow the rules for our region drawing right now, but maybe a region looks like this. And what I mean by that is there's specific rules that tell us how to draw regions in this puzzle. But in general, in chaos construction, you're going to have 6 hidden regions, each of size 6. So this is 1, 2, 3, 4, 5, 6. And they're going to be fully connected by sharing edges. So you can't disjoint it like this. You definitely can't disjoint it like this, right? They have to be connected by edges in some way. And these regions have the digits 1 to 6 exactly once each as well. But it's up to us to discover where those regions are as part of the puzzle. Now, in this puzzle, each region must have exactly 1 thermometer and exactly 1 crop key dot contained within it. So every cell involved in the crop key dot and every cell involved in the thermometer is in that region. And there's exactly 1 of each within each region. So we have 1, 2, 3, 4, 5, 6 thermos and 1, 2, 3, 4, 5, 6 crop key dots. All right, so how do these also are not just visual. Crop key dots, they're all white dots. They separate consecutive digits. So if this was a 2, this could be a 1 or a 3, just as long as they're consecutive in some way. And then thermometers, the circle we call the bulb of the thermometer, and that's going to be the coldest temperature, right? So it's going to be the smallest digit. It's like maybe a 2. And then we have to just get bigger as we move along. It doesn't have to be in any particular sequence. It just has to be bigger. So I could do like 2, 4, 5. I could do 2, 4, 6. I could do 2, 3, 4. I could do 2, 3, 6. It doesn't matter. As long as they just keep getting bigger. Could even do 4, 5, 6 if I want. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. So I want to start with this region here. Let's call that the green region. Because we already start with these 3 cells. Now, we can actually color each thermo, and that might be helpful, because there's only 1 of each thermo. And so if we just give each thermo a unique color, then now we know we have a seed for each of our regions. Now, this crop key dot tells us we have to extend here. Okay, so this region here cannot take this cell. It needs 1 more cell. So it can't take this one because it would have to take both, and that would be 7. So it's going to take this cell or this cell only. So who reaches this cell, right? We can't have blue reach it. It already has 2. We can go 3, 4, 5, 6. Can't quite get there. There's no way to kind of path there. So blue, it doesn't take it. Purple's too far away. Orange is too far away. It'd have to go all the way around. So these are definitely yellow. Now it's tempting. Yeah, I think we have to connect here. Yellow now has 5 cells. They have to be fully connected. And so there's only 1 cell we can add that connects them, and that's this cell. And so now yellow is done. I'm going to draw the border of yellow, and I'm also actually going to draw the whole border of the grid. There we go. And so now red extends here or here. But if red extended here, we'd trap orange. Orange has to keep going, right? Orange is not 6 long, and it only has 1 edge that it can grow along, so it's going to grow there. And it needs to grow again, still only 1 edge, so it grows there. And now red has to take this, and red is done. Nice. All right. Now someone's taking, orange is taking this one, and it's now done. 1, 2, 3, 4, 5, 6. So orange is done. Purple has to keep growing, so purple is going to grow there. 1, 2, 3, 4. It needs a dot. And the only dot it can take is this one. It can't quite reach this one. That would also block off green. So purple's going to take this dot. And now it has blocked off green, but it's blocked off green with just enough cells that green can finish. 1, 2, 3, 4, 5, 6. And it does get a dot. So green is done now. And then blue just takes the remaining. There we go. All right, so we drew all our regions. We're done, right? Now we have to fill digits now. So let's see. We can start here because let's talk about thermos, right? We can pencil thermos with what values are possible, because even if I start with 1 here, I can go 1, 2, 3, 4. That means that 4 is the minimum digit for this cell. It can't be smaller, or we won't be able to fill on enough smaller digits below it. So we could also go, and now how big can this be? We can go 6, 5, 4, 3. So this can be as big as 3. And we just fill in the middles. So that's one way to do it. And so now this is consecutive with 1, 2, 3, which means a 1, 2, 3, or 4 is used up by this cell here, which means we can't do 1, 2, 3, 4 here, or there won't be a digit to go here. In fact, if this is a 1, this must be a 2, right? So that means this can't actually be a 4, because if this was a 4, it forces 4, 3, 2, 1. And that would break this cell. So 6 ends up in one of these two cells. That's an interesting deduction. Okay. The remaining ones are a little bit less interesting because they're 3 length or even 2 length. But let's see what we can do here. There's no 6 in these cells. There's no 6 here. Let's see, these are consecutive. You know what? This can't be a... Oh, no, it could... Can this be a 3? Yeah, if this was a 3... Can this be a 4, I guess is the question. Because if this was 4, this would be 3. But then if this is 3, it forces the thermo to be 3, 4, 5, 6. And so the 4 gets double used. So actually, this cannot be a 4. So that means that there has to be a 2. Because if you think about the easiest way to get here, in my opinion, is across a white dot, you always have one even digit and one odd digit. And so because 2 consecutive digits, one's always going to be even, one's always going to be odd. So what's the even digit that's going to be across this white dot? We excluded 4, so it has to be the 2. So the 2's in one of these two cells, and the 2 is not here. And if the 2's not here, that propagates upward, because now the minimum here is 3, so now the minimum here is 4. Okay, we're making some progress on this. We also have this thermo here. We know, okay, this column needs a 5 and a 6. And so they have to end up on this thermo, and the only way they're doing that is 5, 6 like this. And so now this is just less than 5 or 6, which is not going to be hard to do. The whole rest of the region is 1, 2, 3, 4, which I think I will mark. These are consecutive. That doesn't mean much. There's no 5 on this thermo. And this can't be 5 because we'd go 5, 6, what, right? This is 1, 2, 3, 4 only. This is 2, 3, 4, 5, but not a 5. So this is 3, 4, not 5, 6. And so 5's not in any of these cells. 5 has to go on this white dot, and it can't join a 6. So this is a 4, 5 pair, meaning these can't be 4. And so this is 1, 2, 3, but it can't be a 1 because it's at the tip of the thermo. So this is 1 or 2, and this is 2 or 3. That's limiting. Let's see. 4, 5 pair also affects the rest of the region. Those can't be 4. This can't be a 3 because this can't be 4 or 5. So this, if this was a 3, this would have no value. It could be. We could still do 3, 2, 1, I think. We did get a 1, 2, 3 triple here, though. So this is definitely from 4, 5, 6, meaning this is from 3, 4, 5, 6. We are going to need a 5 and a 6 in this row. And most of the row is a thermo. So my argument is that this is one of the... this cell here is either a 5 or a 6, right? Because if this was lower than 5, 6, like a 4, then we can't fit a 5 and a 6, in, both 5 and 6 in this row. Basically, one of those 5, 6s is going to end up on the thermo. And so that means the biggest digit is at least 5. Because if there is at least a 5 on the thermo, then the largest digit is at least 5. So that's a 5, 6, for what it's worth. That means this can't be 6, because if this is 6, this ends up 5. And there's a few reasons that doesn't work, actually. And so 6 needs to go in this row, and it only goes there. There we go. I didn't even notice there was the 5 there. I just said that this 5, 6 would break this cell, but that's even easier. So now we do need a 5 in this row, and it's going to be in one of these two cells. If this was a 5, this would be 4, and that actually seems reasonable. This 4, 5 pair, so this is 1, 2, 3, 6, but I don't know how to reduce that. Let's see. We know this is from 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6. Let's just mark that. Same thing here, 1, 2, 3, 4, 2, 3, 4, 5. I think that's worth it. Do we want to know about the 5 in this row? Not really. We need a 6 in this row. That's going to end up exactly here, actually. This 6 removes it from here. Interesting. Okay, so that's a 6 for the row. That makes this a 5, which makes that the 6. Not super surprised. That's not a 6 now. This is still any of 3, 4, 5, 6. Ah, but this 5 gives us the 4 and the 5 here. It also gives us the 5 in this box, which has to go with a 4. So now this is 2 or 3 only, meaning this can't be 3 or 4. That's a 1-2 pair, though, so that's our 3, and that's our 4. Okay, that gives us the 3 here. 1-2 pair across this. 4, 5 goes here. Ah, the 5 can't go there, so that's 4, that's 5. Giving us the 4 here, so now this is odd. 3 or 5. None of these are 4 or 5. Interestingly, this can't be 4. It also can't be 3 now. Okay, this is collapsing, I think. This is not 3, 4. We have a 1-2 pair. The 4 goes here. This is 1 or 2 only, so 3 in this column goes here, which makes that a 6, makes that a 5. This is 1 or 2, so is this. 1-2 pair gives us the 3 and the 6. That's not a 3. 1-2 pair gives us 3. That has to go with 2 and 1 there. We get our 2 and 1 there. We get our 1, 2, 1, 2, 1, 2, 1, 2. Last digit's a 3, and we're done. All right, neat puzzle, Asylum. Yeah, I liked how we were able to just kind of find the regions first and then fill in the digits, but it was still interesting even after finding the regions. So really cool construction that you're able to have a thermo and a dot is exactly 1 each in each region and have the regions work and then also have the Sudoku work. So that's a lot of work. So very neat. I enjoyed this. Let me know how you did. And if you enjoyed it, why not leave a like, subscribe, and a kind comment below.